Hey everyone, here's our math problem for today. We are given here 8 raised to x minus 2 raised to x over 6 raised to x minus 3 raised to x equals 2. Find the value of x given that x is an element of the set of integers. You can pause the video and see if you can solve this Math Olympiad problem. Now let's solve this problem together. Since we are after an integer solution for this problem, and since we have here a division operation, let's check first if there is division by 0 that will happen here. So let x be equal to 0 and check what happens to this equation. So if x is 0, we have 8 raised to 0 minus 2 raised to 0 over 6 raised to 0 minus 3 raised to 0. And that gives us 1 minus 1 over 1 minus 1 equals 2. And that resulted to an indeterminate form 0 over 0 equals 2, which is not correct. So here, we know that x is not equal to 0. Next, let's simplify this given equation. We know that 8 is 2 raised to the third. 6 is 2 times 3, and we copy all the rest. Then, let's recall some laws of exponent. Using the power of a power rule of exponents, we can simplify this part here to make it 2 raised to 3x. And we can simplify this bottom part here by recalling the power of a product law of exponent. We have here a product raised to an exponent that becomes the first factor raised to the exponent and the second factor raised to the same exponent. So here, 2 raised to x times 3 raised to x, all the rest are copied. Then notice that we have here a common factor of 2 to the x and 3 to the x for the denominator. So this term divided by the common factor resulted to 2 raised to 2x. We copy the common base and we subtract the exponent 3x minus x equals 2x. Then this term divided by itself is 1 and we copy the minus sign. For the denominator, the common factor is 3 raised to x. So this first term divided by 3 raised to x is equal to 2 raised to x. Then this second term divided by itself is 1 and we copy the minus sign. Next is, let's recall again the power of a power rule of exponentiation. We want this because we can re-express this part here by using the converse of the law of exponent number 3. Applying the converse of this law of exponent, this is what we have. 2 raised to x all raised to the second. That is applying this power of a power rule of exponents and the commutative property of multiplication. Why are we doing this? Notice that 1 can also be written as 1 squared. And therefore, we now have here a difference of 2 squares, which we can factor like this. This 2 raised to x plus 1, that is the first factor, times the same 2 raised to x minus 1, applying the difference of 2 squares identity. The beauty of this is we can cancel out these common factors. So let's do that in the next slide. We have here common factors that we can cancel out. And so what's left is 2 raised to x times the quantity 2 raised to x plus 1. In the denominator, we have 3 raised to x and we copy the right side. And cross multiplication resulted to 2 raised to x times the quantity 2 raised to x plus 1 equals 2 times the denominator 3 raised to x. Now, there's a common factor of 2 here that we can divide. So let's divide by 2. So this 2 divided by 2 is 1. We do not write the 1 anymore. Then 2 raised to x divided by 2 is 2 raised to x minus 1. And we copy all the rest. This is now the form that we are going to analyze. So let's analyze its parity. Let's remember that x is an integer. So if you raise 2 to an integer, several things can happen depending on what is the range of values of x. So let's start first when x is greater than or equal to 2. When x is equal to 2, this becomes 2 minus 1. When x is 3, this becomes 3 minus 1 and so on. But whatever is the value of x, as long as x is greater than or equal to 2, this 2 raised to x minus 1 becomes an even number, because 2 to the first is 2, 2 to the second is 4, 2 to the third is 8, and so on. They are all even numbers. Whereas here, 2 raised to x is again an even number, but we add 1 to that even number, making it an odd number. And when you multiply an even number times an odd number, the result is another even number. So that means the left side of this equation is an even number. Now at the right side, 3 is raised to any integer greater than or equal to 2. So when x is 2, you have 3 squared, which is 9, which is an odd number. 3 to the third is 27, is also another odd number, and so on. So the right side is always an odd number. So an even number cannot be equal to an odd number. That means when x is greater than or equal to 2, there is no solution to this equation. So we now remember this result. X cannot be greater than or equal to 2 because there is no solution there. Now let's take a look when x is equal to 1. Substitute 1 for all instances of x, and simplifying, we have the left side is equal to 1 times 3, which is equal to 3, and the right side is also 3, which is a correct equation. Therefore, x equals 1 is a solution to this equation, and let's remember that result as well. Now let's go to the remaining set, that is when x is less than 0. And what are those integers? Those are -1, -2, -3, and so on. Now another way of writing this is to say that x is equal to a negative n such that n is positive. So when you have a positive integer, here n is an integer. So when you have a positive integer and you get the negative of that, the result is a negative integer. So simplifying now, replace all x with negative n. When you have a negative exponent, that can be written as positive provided you write it as 1 over 2 raised to the positive n plus 1. The same thing here. That becomes 1 over 2 raised to n plus 1 equals 1 over 3 raised to n. Here, n is a positive integer. Now, we can simplify this further. So, adding this part, that gives us 2 raised to n plus 1 over 2n. And then we multiply the numerator times the numerator, the denominator times the denominator, and this is the result. So, any number multiplied by 1 is the number. Here, you have the same base. You copy the common base, and you add the exponent n plus 1 plus n to get 2n plus 1. Copy the right side. Then cross-multiply. This is now our result. And we are going to analyze again the parity of this. And this happens under the condition that x is less than 0. And since x is an integer, this is the case for negative integers. What is the parity of 3 raised to n? If n is 1, this is an odd number. If n is 2, this is again an odd number. If n is 3, this is again an odd number, and so on. So 3 raised to n is clearly an odd number. 2 raised to n is an even number, but when you add 1 to an even number, that becomes another odd number. And when you multiply an odd number times an odd number, the result is also another odd number. Now here, 2 is the base, and 2n plus 1 could be any positive integer because n is a positive integer. So 2 raised to that positive integer would always result to an even number. So you have an odd number at the left side, you have an even number at the right side, which is not correct. And therefore we say that there is no solution for this case. So bringing back all these 4 different cases, here is now our result. We have here the number line for integers. The first result here is for x less than 0, x is an integer. There is no solution. The next case is for x greater than or equal to 2, x is also again an integer. There is no solution. Then for x equals 0, again, x cannot be equal to 0. And finally, here is for x equals 1, which is the only solution for this equation. So our final answer is x equals 1 is the only solution to this given exponential equation. So thank you very much, and we hope to see you again in our next video. Bye for now.